we're dealing with 500 degrees. We want to get exact radians for that. I want to show you another method on how you can do this. This is a shortcut to find your exact radians. But let me explain it this way. Keep in mind, first of all, you can always do the proportion. So what you could do is say 500 degrees over 360 is always going to be equal to something over my 2 pi radians. Simplify your fraction of 500 over 360, multiply both sides by 2 pi. And what you're going to end up getting when you do that, it will simplify to 518th pi, or I'm sorry, 500 over 180 pi, which actually further simplifies to 25 ninths pi, and that would be the exact radians. Now, I kept this written out as 500 over 180 pi because of this reason. What you can do for exact radians is make this connection. We know that a piece of pi movement, again, is half a circle. Okay, so that's a pi movement. That's equivalent to 180 degrees. So what we've done is we're really just converting from radians to degrees and vice versa with this calculation. So I know that a pi is the same as 180 degrees. So how many pieces of pi do you want? Well, keep in mind, let's say I actually wanted just a semicircle. So if I kind of took a side note and said I just wanted the semicircle, what you can always do is use this fraction. You can do something divided by 180 pieces of pi. A pi, again, is 180 degrees. So if I want a complete piece of pi, I would say I want 180 degrees of 180 degrees, which is 1 pi. Okay, so that's correct. Now, what if I wanted a full circle, for example? This same calc would work. 180 degrees, something over 180 degrees pi. If I wanted a complete circle to get the radians for that, I'd say it's 360 degrees. Well, 360 divided by 180 is 2 pi. So it'll work like that. Let me show you one more. What if, again, I'm going to use the same ratio, 180 on the bottom and pi. What if I wanted to compute the radians for pi or for 90 degrees? Well, if you look at the graph up here, 90 degrees is right here. Well, 90 degrees is 1/2 of a pi. I know the answer is going to end up being 1/2 pi. Well, if you put 90 degrees in here, 90 over 180 actually simplifies down to 1/2 pi. So what I've just shown you is if you want to, you can come back to what I did here to always get exact radians from degrees. Again, I want pi divided by 180, and I know the degrees I'm dealing with is 500. Okay. Now going on, getting the radians to the nearest tenth. For this particular problem, the answer for radians to the nearest tenth right here is approximately 8.7. And then revolutions, again, all I would do, I would take 500 degrees over my 360. And when you simplify that down, you're going to get, this is approximately 1.39 revolutions, is how much you'd have to travel to get to 500 degrees. And if you think about it, you go back up here, 500 degrees, here's one rotation, that's 360. Add another 180 to that, that's going to be at 480. Oh wait, I'm sorry, I went too far. One rotation is 360. Add another 90 to that is 450. And then we have to add another 50 to that. So we're going to end up somewhere within this region in quadrant 2, which is going to be about a 1.4 in terms of revolutions.